Everyone, welcome back to SAT Math Question of the Day. Here we are. Here's the question. Please read it, pause the video, and we will get right into it. Okay, you have two linear inequalities. In which of the following does the shaded region represent the solution set of those, basically of those things? Now, we have a little bit of a problem here in that the answer is so big that it doesn't fit on one screen. So why don't I rewrite the questions so that, okay, so we have 3x.
Why don't you show all four responses before you write the conditions?
I don't know. Just let me. Okay, here we go. Okay, got it? Everyone happy? Okay, so basically you just want the solution. Which one represents the solution set? That's what we're talking about. So, okay, maybe it's the most vanilla thing, like just Facette says, following your nose is just to solve each one, y equals mx plus b, and see what it is rather than try to guess x or use other clever methods. Although the other clever methods may be faster. We add a y to this side. We subtract y is greater than 3 minus x, greater than or equal to negative x plus 3. So that one we know there has to be a line where the y-intercept is 3 and it has a negative slope. Y-intercept of 3, negative slope. Y-intercept 3, negative slope. Oh my god, they all qualify. But y has to be greater than that. So this is good. This is not. This is not. This is not. And we luck out because all we had to do was do one of them, and only one of them passes this.
Yeah.
This answer doesn't. Is that right?
Yeah.
So it looks like we don't even have to worry about the other one. So we lucked out. But you never know. It's possible that that we may have had to go further. But this is one approach to doing it. To do the other one, it would be negative 4. Yeah, right. Okay, I didn't divide by a negative sign. You got to make sure if you need inequalities, you divide by a negative sign. You gotta reverse the direction of the inequality sign. Negative 4y is greater than or equal to negative 3x plus 2. Now we reverse the sign of the inequality, and this is 3/4 x minus a half. Yeah, minus a half. Okay. Yeah, they all have a minus a half as the y-intercept. This has a positive slope. Oh, they all have a positive slope, and this is a y less than. Wait a second, though. If it's supposed to be y less than... Hold on. What's going on? Y less than means this gets shaded. And y greater than means this gets shaded. Wait a second. Something is wrong. So this is... what is going on? This is the answer. Oh my goodness. Thank goodness I checked. This also has y greater than. I didn't see it. Ooh. Don't be so confident like me. Do it right. Do it correctly. Okay? So this is the answer. Because I didn't notice that this also is above the... Seth hates when I use such thick style. Thin line. Oh, sorry about that. But it's good I checked. See, this one also has a y greater than. This also has a shaded above the line y is equal to negative x plus 3. And this is shaded below. So this is the solution set right here. It seemed like there's some I did not quite feel comfortable doing it that fast. Seth's just sitting there either... I don't know what Seth's thinking. Can't really tell, but I don't think he doesn't look too happy.
Yeah, I see too many words in algebra.
Yeah? What do you mean?
Too many words, too much algebra.
So you're thinking of doing it, you're thinking of using your brain rather than your paper to do this problem. As opposed to doing it plain vanilla, straight track, do it the normal way. You want to look for a more clever solution by maybe picking points in each solution set and testing them.
No. It's what I said at the onset.
Okay.
I looked at the 4 choices.
Yeah.
And geometrically, each of the 4 choices has a different geometric situation.
Okay.
Choice A, choice A has the gray region in the vertical direction.
Okay.
Choice B has the gray region in the left direction.
Got it.
The vertical up. B has the gray region in the horizontal left. C is opposite A. The gray region expands vertically in the down direction, and the D one the gray region expands to the right.
Okay.
Okay, and so the the combination of inequalities, the signs of the coefficients.
Yeah.
The signs of the coefficients and the direction of the inequality symbol determine for each of the 2 inequalities, which of the 4 conditions, which of the 4 gray regions, or which one. And so I would think of discriminating based on analyzing the givens to pick which of these 4 geometric situations is true.
So you're saying that just by looking at this one here, X must be super big. Is that sort of like what you're saying?
Well, so now I think about how do you characterize going up and down, and how do you characterize left and right?
Yeah.
Well, up and down means you make Y get very positive or very negative.
Right. Okay.
So to see if we're staying in the gray region, I think it's more efficient to characterize which direction we're talking about from this equation, from this inequality, and then do it from this inequality, which will lead you to one of these.
Okay.
The inverse is to try each of these and see which ones match the givens. But so let's try to do it the efficient way. Okay, so if we have this sort of inequality, right. So what happens? What happens is we have the boundary when basically you have equality between 3x and minus 4y, which is equivalent to x being positively proportional to y, and so the boundary has an equation of the form x equals y, and I know that the shape of the solution set to an equation of x equals y is like this, right?
The straight line, yeah.
So this is plus x equals plus y.
Right.
The other direction is where plus x equals minus y.
Right.
Okay. Now, for the direction of the inequality, am I going to be above the 45-degree line or below the 45-degree
Yeah,
line?
y is, we have to be above the 45-degree line because y is greater
So
than
for
x.
x, so as y, so about x equals y. So what do we want? What the region to be great is one where we can make x bigger and bigger and bigger and bigger and bigger,
Right?
and it will still be bigger than y if y is constant, right?
Right?
So so uh so x, like, it would be greater than y means you're going. Now I'm going to use the gray. Do I have a
No,
gray?
y is
Oh,
greater.
stop! Don't interrupt me. So for this one, we go in this direction. Now, for this one, we have x is greater than minus y. So x is big, and x should be greater than minus y. That's down here, right?
Okay.
X is big, and y is. Where am I? X is greater. X be greater than minus y. You know the. So again, I'm floundering around. Is it up here? Is it up here or is it up here? Which one? So let's see. Let me think. If we make x equals y, if we go along x equals y, no, not x equals y. If we go along, uh, gosh, can I think? How can I think about this? Let me think about this. So we're in this region. If x gets big, 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 and y is constant, we're okay, right?
I'm not going to say anything.
Like here, this is satisfied if x is a billion and y is 0. And x could be bigger and bigger and bigger. If x gets smaller, 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 it will eventually become less than whatever minus y was, so we're no good. So for this one, the gray region is to the right. And for this one, the gray region is to the right. And so we pick the choice where the gray region is to the right of both the 45-degree line and the minus 45-degree line. And so that leads me to that answer.
So if we go back to the videotape and we look at how long it took me to do it, and then we look at it and we look at how long it took Seth to do it, granted, we were both talking, so we were doing it slower than we would do in real life.
Yeah.
You could see I did it faster than you did, Seth.
Yeah.
Okay, so your method is great, brilliant, and wonderful. And we'll talk about where our backgrounds come from. But I think the normal straight track way of doing it seemed to be faster. Because you don't have to think as much. Also, notice you were actually thinking, you were actually saying, oh, let me stop and think. Did I stop and think? No, I just plowed through and just did it mechanically.
Well, thinking is good.
No, it's not.
That is my thing.
Time.
I am a thinker.
Yeah. But you're doing one question. You are not doing.
Memorialized by Rodin.
Silly. Stop it. You have to do 30 to 50 SAT questions in a limited amount of time. You have brain power. If you start thinking too much on any one problem, that uses up your ability to think in the future. You just get tired. Your brain just gets tired. It's perseverance here. So
that is why I'm very happy that I no longer ever will have to take an SAT.
Yeah, but that doesn't go over well when we're talking to people and going over how to study for how to prepare, how to analyze, how to approach problems for the SAT. Let's be serious. So the way Seth did it seems to be pretty clever, but it requires a lot of thinking and a lot of understanding, and I don't think it's worth it. Sometimes it is worth it. Sometimes just understanding this thinking, you're able to do the problem in 3 seconds. But here, he had the worst of both worlds. He was thinking too much, and it was taking him longer. Of course,
Well, I
I
have another approach is to test 1 point.
yes, testing 1 point is a valid
So
thing.
testing 1 point for this one is to test a very large X.
Exactly. That's exactly.
And 0 equals Y. That means test the point that's up here.
Exactly. So that's
For
not
this
a fair
one,
approach.
we test the point that is over here.
Yep.
X is very, very, very
right.
much less than 0,
X is negative
and
100.
Y equals 0.
Exactly.
Right?
Exactly.
And test those. Yeah, that is much better. Okay, but again, the thing is, using, understanding, enjoying math is a different game from the SAT.
Yes, but we're going over the SAT. We can talk about doing problems in an enjoyable, clever way, but that's not our audience. People are
okay. Well, I think for our audience, this idea, this is given the sample question. It's likely that there'll be questions like it in the real SAT.
Yeah.
So you might as well pick up a new trick.
Yeah, I think the alternate trick of doing it straight like I did is to test 4 easy points, making the observation that each of these 4 answers are very different from each other.
Yeah.
Very, very different. So let's test this one. This would be 0, negative 100. So X is 0. So we blow these off. Now, negative 100. Does negative 100 work here? Wait, what did I... Oh, 0 is 0.
Negative
right.
100 gives us a very positive thing on the right, so it doesn't.
Yeah, so negative 100 here doesn't work because 0 is not greater than. So this you have to throw out. No, I'm sorry. This you have to throw out, right? Because 0 is not greater than 3 minus a minus 100. So you could just go through and you could just test 4 extreme points, like 0, negative 100.
Yeah.
That's not a bad way to do it. That is probably... That is not a bad way to do it. That may be faster than doing it this way, the straight way. So I'm guaranteed that who knows guarantee. It's very unlikely that the answer that they gave in Con does that way, but it's 0 chance that they did it your way. Okay, so let's see how.
Okay, so please, I want to show one more idea, and then we'll move on.
Sure.
To the answer. So please clear it. I'll show you the idea.
I'm one step
Okay,
ahead.
the idea is this. You take any of these figures.
Yeah.
Take any of these figures, like that one. If you zoom out, look at it from a distance, what you see is, here are the axes, right?
Yeah.
And as you move out, the 45-degree line and the minus 45-degree line and the other line get close. The intersection point seems to move closer and closer to the origin.
Okay.
And move out even more, it looks like this.
Okay.
Where the gray region is to the right. Okay. And so you could analyze. So you could analyze the given inequalities as if the constant the constant terms were 0.
Right. Yeah.
Right.
That makes sense.
Yeah. So you could ignore those constant terms, treat them as zero. The coefficients determine the slopes,
Right.
of the boundary for the of the inequality region.
Right.
All right.
Oh, I see. So Seth, saying that just ignore the 3
Yeah.
and just ignore the 2.
Yeah.
And you're saying that this becomes negative y greater than or equal to negative x, because I'm moving the negative y to the other side so I don't get confused. And this is simply y is less than x. And this one is, and ignore the coefficients also, x minus y is greater than 0. Negative y is greater than negative x.
Wait, wait, wait.
So y
Is this check this?
Wait, and
That doesn't
y
look right.
is less than x. So you're saying that, wait, but they both say y is less than x. So I don't know. I missed a
No, you made a mistake in the second one.
I made a mistake you mean this one?
Yeah.
X minus y is greater than or equal to 0. Negative x is greater than. Oh.
The second one.
Oh, this one.
The
yeah,
one below.
I made a
Yeah.
mistake there. Negative y. Oh, I gotta move this to positive y. Right. Positive y is greater than negative x.
Yeah.
Oh, yeah. Y is greater than negative x. And y is less than x. So, y is greater than negative x, which is this one. And y is less than x is this one, so this is the answer. Yeah, that's a really good way of doing it.
We mathematicians call this approach asymptotics.
Right. You just look at massively large behavior. You take this says it all right here. If your scale is 1,000 here, then you can barely notice any detail at the bottom. And then you realize that this is the answer. Yeah, that's a good way of doing it. But of course, now we should show the answer, but I can't resist telling the different approach. Seth is a PhD in mathematics. He's been teaching for a lot of years. He's professor emeritus in University of Albany in computer science. I have a PhD in mechanical engineering. We come from different perspectives, and we're also brothers. That helps. And so Seth has this approach, this highly sophisticated mathematical approach. That's great. Yeah, that's a good way of doing it. That's something to keep in mind, everyone, is to just think about what happens for large x and y. It's common sense.
You might also notice is that of the 4 choices, all of them, had the same intersection.
Yes.
Of the boundary lines.
Yes, that's right.
And so since there's no variation in the intersections, then an SAT answer need not bother calculating what the intersection is.
Right, exactly. But that's just, most people, everyone taking the SAT in the United States after the spring or starting in March of 2024 is going to have a calculator, and I think it's the Desmos calculator. X is greater than y minus 3.
Yeah.
Let's do it. Desmos. X is greater than y minus 3, right? Okay. X is greater than y minus 3. My goodness, you could do this. You could just do this problem using the graphing calculator and be done with it. Because then you go here and you give the second one. We'll do y is greater than x just to show, right? Boom, there we go. Okay, so you can play with the graphing calculator. You could probably do this.
Well, make it minus x. Y is greater than minus x.
Yeah, there we go. There we go, and that's the answer. Right. So pretty sure we should really check this ourselves. But when you're practicing on Blue Book, check to see whether the Desmos calculator that they give you will give you multiple. Can you do multiple graphs? Probably it will, but this is something to check. But you will get a Desmos graphing calculator on the SAT. So you could just do this question using your graphing calculator. It'd be interesting to see whether in the answer sheet, because the what we did is we're playing with the Khan digital course, and they know that you're getting a graphing calculator. I wonder whether in their solution they just say, "Hey, just use the graphing calculator." They probably don't. So anyway, we always must think this. Seth and I grew up without calculators, or I grew up with a very simple calculator, and certainly not a graphing calculator. So we never think like this. Our brains are just not programmed literally to think.
I grew up with a slide rule.
Seth grew up with a slide rule, which is not a graphing calculator. Right. So that means we have to stop ourselves sometimes and say, hey, just use the graphing calculator. So anyway, without further ado, we've done enough talk on this. All right, so let's try D, and let's check it. Okay, good. And now let's see how we answer this question. Oh, look. Okay, great. Notice they're not saying to use a graphing calculator. Okay, and let's make this bigger for our audience.
Oh, come on. Slope intercept
form. Well, that's what I did. That's what I did. That's the plain vanilla approach where you don't have to think about you don't have to really think, well, is there a clever way to do this? You just do it. And you just do this, right? And then you just keep going, right? Just like sort of I did.
Yeah.
I cut corners and I saw, well, maybe only one of them has the right shading. I was wrong, but I caught myself.
Yeah.
Yeah. So this is just the standard way of doing it. So This is our thing. We like to offer different approaches on different ways to approach SAT math questions. Sometimes just straight. We hope to do the straight approach, and then we do other approaches that one should consider. Okay, so I guess that's it for today, right? Other than to say that a good approach to study for the Math SAT is to go to Khan Academy, look up either the digital and non-digital courses, and take those courses because they partner with the SAT people. And of course, practice on as many practice SAT questions as you can. That is sanctioned by the SAT, that are given by the SAT people. That's it for today, right?
That's right. Okay, bye, everybody.
Okay, everyone, have a great day. Bye-bye. And please like us, dislike us, and please, if you can, give us comments so we get feedback, because feedback is really important for us. Okay, take care, everyone.